Welcome, folks, to another PyMCon, the first one of 2024. I have Linus and Anna here. They are going to be taking you through Bridge in a series of tutorials and videos later on in this month of January. But for now, this is the interview. I want to give the floor to them and let them give an introduction about themselves. So, Anna, would you like to go first?
Sure. Hi, I'm Anne. I'm an assistant professor at Durham University in the Department of Computer Science, actually. So I mainly focus on kind of the interface of UQ with other things like computation and scaling things up and stuff like that. But my background's originally in mathematics. And I've been actually in most of the acronym in STEM. So I've been in the engineering department, in the mathematics department, and now in the computer science department.
And if you don't mind for the audience, what does UQ stand for?
Ah, Uncertainty quantification.
Awesome. All right. Linus?
Yeah, so I'm currently doing a postdoc at Karlsruhe University in Germany. And kind of similar to Anna, I have a background in numerical solution of partial differential equations, which plays a big role in numerical simulation of physical phenomena. And taking a turn towards uncertainty quantification and the more statistical aspects to this during my PhD. And yeah, since then went down that road. Also have a bit of a focus on high performance computing. So basically whenever the sort of intersection of simulation, statistics, and high performance computing comes in, that's what I find most interesting.
All right. And so you both are frankly quite accomplished with PhDs and at universities. When I was younger, I remember when I heard from folks like you, I'd always be curious, am I ever going to make it or how am I going to get there? But I've now realized that everyone starts somewhere. So I wanted to ask you both, way before you had your fancy titles and your professorships and were in universities, how did you get started in these fields of, high performance compute or uncertainty quantification? What was your path like?
So I think that I also always looked at it like this until suddenly I was an assistant professor. So I kind of started out and I always thought, like, in each step I thought, oh, everyone else is so much, above me. And then suddenly you look back and you go like, wait a second, what just happened? And so I think that for most people it's just like continue on in some sense and continue to just do what you do and you'll get there eventually. In terms of how I got into high performance computing and UQ, that also I just kind of drifted into. When I started studying math, I thought I was going to go into pure math. So I was really into representation theory and things like this. And then I had a really, really good numerics lecture. And I ended up doing way too much numerics, and now I'm here.
Yes, so for me, I can very much agree. It's not like you lay out any plans from the very beginning. In fact, I remember when I started studying math, my first goal was just get admission to the master's program and then head off to industry with an okay degree, hopefully. But yeah, I mean, it turns out I just like research. It works well for me, so I continued that route. Then again, I wouldn't keep anyone from changing tracks. I've seen people do it who did very well from noticing that what they have tried actually doesn't work. And I have actually very high respect for people who say, let's go a step back and try something else. But yeah, I mean, I guess that's maybe a different question. So when it comes to how I got started, in fact, quite a long time ago, my father, when I was a young kid, gave me a programmable calculator, which was maybe an odd gift for a young kid. But he just noticed I was interested in numbers and calculating and so on. A couple of days later, I basically figured out how to program the thing more than he did, I think. And yeah, since then, I've always been doing software a bit on the side as a hobby. It's cool, got into math. That's what I started studying because I found it interesting. But software has always been sort of a side project. And turned out in numerical mathematics, you actually get to do both. So that's perfect. And that's basically how the thing comes into this, where I'm half a mathematician, maybe even half a computer scientist at the same time. And the link between sort of theory, high performance computing and all that is what I find really the most interesting to me.
What interested you both in uncertainty quantification? So typically, in PyMC, in the early community and the PPL community, we say Bayesian statistics, but I actually like the term uncertainty quantification because, rather than just one guy's Thomas Bayes name on things, the idea is we're in various forms, quantifying uncertainty. For me, that's been industry, and for other folks, it happens to be in medicine or finance, whatever it may be. For you two, what is interesting about uncertainty quantification?
I guess my background dictates that a bit. So I come from numerical solution of PDEs, so simulation problems. And from that perspective, it's quite easy to say a traditional deterministic simulation gives you an answer, it gives you a prediction. But what good is any answer or any prediction if you don't know the degree of certainty that this comes with? Right? Let's say you want to simulate an aircraft wing. Your simulation is going to give you an answer, but you probably don't want to get into that airplane unless you know that this simulation is somehow taking into account something like random manufacturing defects, or maybe situations that have not been anticipated or that are sort of outside of the norm that you would expect, right? So to me, what I find a very strong motivation is to actually get more reliable and more sort of complete information out of simulation systems. And especially since you already mentioned Bayesian inference turns out to be really helpful in actually understanding better how models themselves work, right? How certain parameters interact, how certain aspects of it explain the real world that goes on out there. So to me, it's always this aspect, getting essentially more information out of models and getting a deeper understanding of them.
That makes sense. And I have to say, I actually love that answer, because that's how I got into Bayesian statistics. Was I was designing parts and aircraft parts, things like that, and was like, well, what if they fall out of balance and the whole thing explodes? So when you think like that, then you're really motivated to learn uncertainty. But I don't want to steal your time, Anna. What got you into uncertainty quantification in particular?
So I'll give a slightly different perspective on this. So I did my Diplomarbeit, which is a master's thesis essentially, on high-dimensional quadrature. And so when I started looking at uncertainty quantification, it was as a way of increasing the dimensionality of my problem and having something to solve. So I started with kind of stochastic PDEs and things like that. So in some sense, we're now getting into the era of exascale computing. And in that context, uncertainty quantification gives us also a way of filling up these computers with something that is actually useful, rather than just increasing the size of the problem in a way that doesn't actually give us more information.
All right. Thank you both for those answers. And so the very last question I have is, the best way to reduce uncertainty I found in my life is just live life and have experiences. Get more data is typically the word. So now you folks have a lot of experience in this field. What advice would you give to somebody who's just starting out now?
So one advice that I'd really like to give is, and it's maybe even a mistake I made in the very beginning, since I wasn't really embedded in much of the UQ community at the time. I was coming from that simulation side, so I was one of the few in the department who moved in that direction. So one advice that I would give is to try and really start small, because in the sense of when you're trying to do something like uncertainty on a simulation problem, try and really dumb it down to some very simple situations. Because it's tempting to, of course, go right ahead and solve the big problem that you're actually after. But one thing that I did really underestimate in the very beginning is that, especially with inverse problems, that whole statistical aspect becomes an entire modeling problem of its own. So I guess to statistics people, that's maybe obvious. But if you're coming from the simulation side of things, this is really can get as complicated as the actual modeling of a physical process. So approaching it step by step is really a good idea, getting this sort of statistical side sorted, and then step by step building up until you reach the uncertainty of the simulation problem that you actually want to go for.
Yeah, for me, I think that there's kind of two aspects. There's the encouraging side of things, which is, just try things out, especially with tools, I think, like PyMC. We have the opportunity to just throw some simulations and see what sticks. And I think that that's the best way of kind of getting familiar with things. Just try them out, and it will go terribly wrong, and it doesn't really matter. And I think that's what I always tell my students, at least, is just go for it. But then the other aspect of that is, of course, that you need to be able to assess whether what you've done actually works, and you need to be willing to then put the time in afterwards to improve on what you've got initially. So you can't let it end there with, oh, I've tried it out and I've gotten some result out, I'm happy now. So my advice in that regard is to always find some sort of a really, really simple method that you can benchmark against, and don't assume that what you've done in a very clever way is necessarily better than the very naive algorithm, let's say Monte Carlo.
All right.
Oh, and maybe that's an interesting way to segue into your embrace, right? Because now we can say, makes it very easy to just experiment with different tools. Like, let's try out PyMC. If that doesn't really do the trick, let's maybe try a completely different method. That kind of flexibility is really, I think, what we need in the UQ world, and we currently don't really have yet. Stay tuned and have a look at the UMBridge talks that we'll show.
I was going to say, that's a great segue. So folks, you heard it from Linus himself. This is just the interview. So as always with PyMCon, in Discourse, there will be all the posts to their the recorded tutorials and then some synchronous sessions that are coming. So don't miss out on this. You can find all the details on Discourse and PyMCon.com. For now, Anna and Linus, I wanted to say thank you so much for taking the time out for this interview, and then also for the extra content you're going to be providing later this month.
Yeah, so thank you very much for inviting us.
Thank you.
Cool.